Here we go. We have a question. Put marbles in bags. You have k bags. You are given 0 index integer array weights and the element is the weight on the ith marble. You are also given k. We need to divide the marbles into k bags according to the following rules. No bag is empty. If the ith marble and jth marble in a bag, then all the marbles with an index between I to j should be in the same bag. If a bag consists of all the marbles with an index I to j, then the cost is the first and the last value. The score after distributing the marble is the sum of all the cost. And we need to return the difference between the maximum and minimum score. So we have given this example, and in this, so if we divide into two portion, first portion will be this, second portion will be this. So this will give me the minimum score. In this subarray, the first element and the last element is 1 and 1. In this subarray, first element and the last element is 3 and 1. So the total is 6. This is the minimum. What is the maximum? So if we distribute like this 1 3 and 5 1. So in this subarray it will give me 1 plus 3. In this it will give me 5 plus 1. So the total is 10. We need to return the difference between maximum and minimum. So it will be 10 minus 6. The answer is 4. In this example, the maximum score or the minimum score is same only. So we need to divide into two portions. So first portion is 1 and the second portion is 3. Right. So the maximum value is same as it is as minimum value. So max minus will give me 0. So let's build the approach. First, let's take a example. And let's take the portion. We need to divide into 5 portions, right? So first let's divide it into the 5 portions, or let me write four portions. So I am dividing into 4 portions. So this is one of the answer. It may be maximum, it may be minimum, or it may be none of that. So what is the answer? What is the answer? It is this, right? Yes, this score is this, and this is the total score. This is the total score, right? And if I am making a cut on index I, so I am including this value, and I am also including I plus 1th value, which is this value, right? So if I am making a cut on ith index, I am considering this value and also considering the next value. So what I am saying is, if I make a cut on ith, so cut on ith will divide into two portions. First is this portion, second is this portion. So I have to take, this is my ith index, so I have to take, this is first, this is last, this is first, this is last. So I will consider these two, right? I will not talk about this first and last because this will handle automatically. So I need to consider the ith index. It will divide into L plus R, L plus F, which is last of the first portion and first of the next portion, right? So it will divide into two portions and I have to take both of the values. I need to take the adjacent values, right? I need to take the adjacent values. So let's first find the adjacent values of this subarray. Let me name ADJ. And what is the adjacent value? So 2 plus 3, 5. 3 plus 8, 3 plus 5. 5 plus 6, 11 plus 6 plus 2, 2 plus 3, 3 plus 4, 4 plus 8, 8 plus 9, 17. So this is my adjacent value. Then I need to make uh, four portions, or in other words, I need to make k minus 1 cuts. If I apply k minus 1 cuts, it will divide into 4 portions, right? So I will sort it, or I will sort the array, and I will choose 3 maximum values, right? I will choose 3 maximum values. So the maximum values is 17 plus 12 plus 11. This is the maximum 3 values. So I have divided into 3 portions. What are those portions? So let me write the portions. So this is the portion, and if I have to calculate, so the cost will be 2 plus 5, and here it is 6 plus 4, here it is 8 plus 8, and here it is 9 plus 9, right? So this is the maximum. I know it is different, but let's first focus on this concept. Then the next thing is the minimum. I need to find 3 minimum values. So 3 minimum values is 5, 5 and 7. And what is the subarrays? So this is the subarray. So I have divided this subarray into 4 portions. So first I will make cut on this index, then make a cut on this index, then make a cut on this index. So it will divide into 4 portions. So this is my minimum, and let me write the cost. So it is 2 plus 2, it is 3 plus 2, it is 3 plus 3, it is 4 plus 9. So if I do max minus min, so what will happen? So this value will cancel out this value, and the last value will also cancel out the last value. So what are the remaining values? 5 plus 6, then 4 plus 8, then 8 plus 9, minus 2 plus 3, 2 plus 3, 3 plus 4. Isn't this value 11? Isn't this value 12? Isn't this value 17? Right? We have this value. Isn't this value 5? Isn't this value 5? Isn't this value 7? Yes. So we got 17, we got 12, we got 11, minus we have 5, then 5. So I hope you understand that this thing is the summation, and here we have summation of the minimum cost. This is the maximum cost minus minimum cost. So it will look like this: 5 plus 5 plus 7. So we got 3 maximum values minus 3 minimum values. So the answer of this is 7, 8, 9, 10, 40, minus this, which is 12, which is 28, which is 28. So let me verify it if this is correct. So there is some calculation mistake. So the summation of 5, 5 and 7 is 17, which will give me 23 as the resultant. So that's how this will work. So first I will make this adjacent array. Adjacent array is simple. Then we will sort this, and then we will select the 3 smallest values, or k minus 1 smallest values, then we'll also select k minus 1 maximum values, and then we will do max minus min. And let's code this. First let's make the adjacent array of length n minus 1. We don't have n. Then the next thing is just calculate the adjacent values adj of I is equal to weight of I plus weight of I plus 1, right? Then we need to sort it. Then we select k minus 1 values. In the minimum I will take long, and I will also select k minus 1 bigger values. So let's write I here, while I is less than k minus 1, I plus plus, but in this case I will select from last. It is n minus 2. My array size is n minus 1, so the last value is n minus 2. Max plus equal to adjacent of I. Just return max minus min. Let's run this, and we have an error here. There's some mistake. I need to access the last value. The last position is j. So first I will access the last, then the second last, then the third last. So let's submit this, and let's discuss about the time and space complexity. In this code we have the sorting, so it will be n log n. What about space? Space is order of n. That's all, and the code is provided in the description box. Thank you all for watching this video.